Everybody is welcome to my YouTube channel. Today I want to discuss the red-black tree insertion of the red-black tree. How the data is inserted at the red-black tree. Data inserted red-black tree we can divide by two parts. First is like the BST binary search tree, and second part is the like the ABL tree. The ABL tree, mostly it is not fully like of the ABL tree because it consists in taking the only recorder, only the searching procedure, that is the numbering procedure, like the BST, sorting order is like the BST, and balancing factor, rotation balancing, that is from ABL tree. And now another part it is added, that is the coloring. So the red-black tree consists of three parts. From it is the number sorting order like the BST, another is coloring part, it is only own parts, and another is the balancing factor, that is the rotation factor. So rotation is already from the ABL tree. Already we discussed the ABL tree. First, the color of the node of the root node will be black color. It is the first and foremost condition of the red-black tree. Suppose the value is 50 and the color is black. Root node always color black. When we are going to insert any node, if the tree is black entity, then the node will be the root node and the color will be the black color. Now I am inserting the second node. Inserting process two inserting process of the second node, that is it can be added at the left child of the 50. The color is less than 50, as value is less than 50, otherwise it will consist at the right child of the 50 when the value of the inserted node is greater than root node. So two options is there. If the less value, then left child. If the right value, greater value, then at the right child. Now I am considering that the value is less than 50, that is value is 40, and the color of the inserted node always red. So this is the red color inserted node, value is 40. Now I am inserting and I have to check now whether it is a red-black tree or not. Red-black tree condition, there are three conditions. First condition is root node always black, and if any red confliction is occurred, or if not occurred, it is okay. Occurred, then it will be resolved first. It is the black node, it is the red node. So red confliction is not occurring. Red confliction means two red node in one sequence. So no red confliction, consecutive red color. So no consecutive red node is present there. And now I have to see that the path from B to leaf, that is the leaf node at the 40, leaf node consists 40, node 40. So two black node, leaf node is present here. From 50 to leaf node, there are only one black node. And there are only one part. So C condition already fulfilled. Now I am going to insert another node of the red-black tree. Another node. So similarly, as like our previous following procedure, that is, if the node value is greater than 50, it will take right position. If the less value, node value greater than 50, less than 50, and also less than 40, then it will take the left position. Now I am now suppose the value of the node is less than 40, that is 30. Suppose the value is 30. So it will be, the color of the 30 will be red. So red confliction already arrived. How to resolve this red confliction? By rotation. Rotation like ABL tree rotation. And the rotation will be R, it is LL. Rotation will be LL rotation. LL rotation means in this way. So 40 will take in this position, middle position, center position, and 50 will take the right child of 40, and 30 will the left child. Color will be changed. But how the color will be changed? The involved node is involved. Which node is involved at the rotation? Two nodes is involved at the rotation. Node 40 and node 50. So color of the only two nodes will be changed. Color of the 40 was R, it will be black. Color of the 50 is black, it will be red, and color 30 will be no change. Okay, so this is the first rotation of the node, and this rotation is done at the third node insertion process. Suppose, and now I am inserting the another node. If the node is greater than 50, then it will be added at this position. Suppose it is value is 60. Now the red date confliction will arrive. If the node is greater than less than 30, then it will come as a left child of 30. Similarly, the red date confliction will be arrived. Now suppose this is the value 60, and then we have to check it is correct as red black tree. No, it is not correct as red black tree because red date confliction already reached. So how this resolve the problem? Problem will be resolved in this way, that we have to see. I have to see the uncle of 60. Uncle is 60 is 30. 50 is the parent, 40 is the grandparent, and also 30 is the uncle of 60. Because 30 is the sibling of 50, so 30 is the uncle of 60. The color of the uncle is red. If the color of the uncle is red, then rotation is not required. Rotation is not required, only the color will be changed. What is the color and which node's color will you change? 3 nodes color will be changed. For 30, 50 and lastly 40. 40. If the 40 is the root node, then no color of the root node will be changed. Only 2 nodes color, 30 and 50 will be changed. So it was red, it will be black, it will be black. And the root color of the 40 will be as it is. Now this is the final tree of the red black tree. If we see that it is a red black tree and see that the root is black, from root to leaf 2 black nodes is there, and in this part root to leaf 2 black nodes is there. No red date confliction is there, so it is a red black tree. Now I am inserting another node that is less than 30. Suppose the value is 20. Color will be red. After inserting 20, it is maintaining the condition of the red black tree. It is maintaining the red black condition of the red black tree. Why? Because no red date confliction is arrived. 2 black nodes at each path, and color of the root node is 40. So it is like the red black tree. Now I am inserting another node. But going to insert another node, I want to discuss similarly another thing. That is, when we are inserting any node of the red black tree, first part, the inserting process starting by the BST, binary search tree. As per binary search tree, we consider the value of the node. If the value is greater than node, then it will be the left child, take the left position, and if the value of the node is greater than 50, less than 50 is left position, greater than 50 is right position. It is like the BST tree, binary search tree. But then the second position is like the AVL tree. AVL tree is maintaining the height as per balancing factor. But in these cases, height is not maintained, but balancing factor is maintained by 2 rotation, by 2 points. One is rotation, another is recoloring. So recoloring is the process, and coloring also, your rotation is the process. By 2 process, the balancing is occurred. Now we have to see, now if in this way we keep the balance, and by rotation, by color rotation, we keep the balance, how the node is inserted and its balancing is occurred. Suppose the node is 10, 1, 2, 50, 20, 0, 35, 40, and 99. Suppose the value of the nodes is such, and we have to insert one by one. I am inserting first node 10. Next one, n is less than the black color, node will be always black. 1, left child of the 10, this is the left child, and the value of the 1, the color will be red. And first inserted node, color of the inserted node is always red color. Now 2 is greater than 1, so 2 is at the position, and the color of the 2 is red. But red date confliction is already occurred. Now to resolve this red date confliction, how the confliction will be resolved? First see, what is the color of the uncle of the 2? First we have to consider, we have to search the color of the uncle. Father is 1, grandfather is 10, no child of the grandfather is there except 1. So no uncle of 2 is existing. When the uncle of the inserted node is null, then the rotation is required. Null uncle rotation is required. So how rotation is performed? Here 2 rotation will be occurred. First rotation, that is LR. LR rotation. First rotation at lower parts, that is rotation, left rotation, and then the L rotation. Left rotation means in this way, that is 1 and this part 2 will swap the value. So 2 will take that position, 1 will come at the just at that position. And 2 colors, color of the 2 is R and 1 color of the 1 is R. So the first rotation is complete. Second rotation, but after first rotation, no color will be changed. After second rotation, the color will be changed. Then second rotation means in this way, that is 2 at the center point, 10 is the that point, and also 1 is at this point. That's the left child of 2. Color of the 1 is R. Color of the 2 is black, will be black. Color of the B is 10 is red. Color will be changed. But which node, the color of the which node will be changed? The nodes who is involved in the rotation. The 2 is involved in the rotation, second rotation, not first rotation. Second rotation involvement nodes is 2. The nodes 2 colored from red to black. 10 is involved, so black to red. Okay. Now I am inserting the next node. Next node, that is 1, 2, or 10 already inserted. 50. 50 is the greater than 10. Okay. This take this position as a red color. 50 and color will be red. Rotation is required. Yes, rotation is required because uncle is red. When uncle is red, rotation must be required. No, sorry. Uncle is red and rotation is not required. Only coloring is required. So color, which color of the nodes will be changed? 2 nodes color of the will be changed. That is parent and uncle. And grandparent's color may be changed if it is not the root node, but it is a root node. So no color of the grandparent will be changed. So 2 nodes color, that is R, 1 and node 10 color will be changed from red to black. From red to black. No inserted nodes color will be changed. So color of the 50 node will be unchanged. Okay, the color already changed. Now see the procedure to examine whether it is red black tree or not. From basic B point, from root point to nodes point, that is 2 black nodes at that side, and this side contain 2 black nodes. So, and root node is already black, and no RR confliction, red confliction is occurred. So it is a red black tree. Second nodes, that is 20. 20 at the position of the 1, that is right child of the 1, greater than 1, but no, 2 will not come at that position. 20, but greater than 2, greater than 10, but less than 50. Greater than 10, greater than 10, okay, less than 50. Less than 50 means 20. This is the position of 20. Color will be red. Okay. Now, red confliction is occurred. How to remove this red conflictions? Uncle, I have to see the uncle, color of the uncle. Uncle, that is the grandparent, but uncle is null. No left child is there. So when the uncle is null, the rotation is required. What type of rotation is required? It is R L rotation. RL rotation. First rotation at the lower parts. So 50 and 20 will change the position of their position. That is swap the value, and 20 will come at the 50 will come at that position, lower position, and value is color is red, and 20 will occupy at the position of 50. Color is red. Thus they swap their value. Okay. Then rotation. Final rotation is required. That is in this way. RR rotation. RR rotation means 20 at the center, 10 will come at that point, and 50 as it is. Ten black, it will be red. 20 red, it will be black. Okay. Okay. So 20 black, 10 red, 50 red. If we change the factors of the red black tree, this note, two black note, this portion contain two black note, okay, and one is the red black tree, root is black. So the condition is fulfilled. Now I'm inserting the second note, that is 50 already inserted, 20 already inserted. Now we have to insert 0. 0 means less than 1. Okay, color is red. After inserting 1, inserting 0, red date confliction is not arrived. So the color, the tree as it is, like the red black tree. Now inserting 35. 35 is greater than 20 or less than 50. That is in this position. 35. 35 color will be red. So again, red date confliction is arrived. I have to remove this red date confliction by identifying the color of the uncle. Color of the uncle is red. Now rotation is not required, only coloring is required. So color of the uncle will be changed. That is from red to black. Color of the parent will be changed from red to black. And also the color of the root will be changed. Color of the grandparent will be changed if it is not a root node. It is not root node, so color of the grandparent will be changed from black to red. Okay, this is the final position of the tree after inserting 35. Now I am inserting 40. 40 is the greater than 35, less than 50. 40 will come at that position. And the color of the root node will be red. But again, the red date confliction is arrived, and the red date conflictions will arrive, but the color of the uncle is nil. No color, no red child, no uncle of the node 40 is existing. So rotation is required. Okay. Rotation is required. Rotation node is 50, 35, and 40. This is the combination. R, 35 is R, 50 is the black node. So the combination, the rotation is required. Rotation name is L, that is L, and that is R. LR rotation. If we want to perform the LR rotation, first we have to perform the lower portion of the rotation of the lower portion, that is 40 and 35. We will swap their value. 35 and 40. 40 will come here and 35 come at that position. Okay, both color is red. This is red, this is red. And now we have to make rotation, that is right rotation. So 40 will be the at that position, 50 at lower position, and also 35 at the position. Color of 35 red, 40 color of the 40, that is red to black. 50 color of the 50 will be black to red. Okay, so this is the final position after rotation of the lower position. So 40, 35, 50. 40, 35, 50. 40, 35, and 50. Color of 50 is red, color of 40 is black, color of 35 is red. Okay, now 50. Now last number, that is 99, I have to insert 19. 99 is greater than 15. 99 greater than 50, okay. Color is red. Red, that confusion is already arrived. Uncle, color of the uncle is red. So only the color will be changed to maintain the red black tree. Color means color of the P40, grandparent color, parent color, and also color of the uncle. And grandparent is not a root node, so must be changed. So the color of the parent, color of the grandparent from black to red, color of the uncle from red to black, color of the parent from red to black. Already changed the value. Now I have to examine. I have to take test for testing purpose. I have to see whether it is red black tree. No, another tree is already changed. Basic note, the root note is to black color. First condition is fulfilled. Second condition is from root node black B to the leaf node 0. That is, I have two black note. If we examine another root, that is from this root, if we consider this root, the two black note is there. If we consider this root, two black note is there. If we consider this node, also two black note is present. So three conditions is already fulfilled. First condition is root black. Each and every part there are same number of black note, that is 2. It is not required, that is always it will be 2, but it is here, it is true. And no red dead confusion is occurred. So this is a red black tree, and it is already maintained the all colors conditions for the red black tree. So I will discuss the insertion of the red black tree. If we get any value, so no problem to insert at the red black tree. But we have to consider the condition. First condition is root will be always black. Leaf node, that is the lower node, will be null value. And the factor, another factor is each and every path from root to leaf, there are same number of black nodes, and no red dead confusion will be occurred by any means. So this is the red black tree insertion process. And in case of red black tree insertion process, we have to combine two types of red black tree insertion process. First is binary search tree insertion process. We are taking the procedure of binary search tree insertion process as per first insertion process, that is sorting order. And secondly, we are taking from AVL tree the rotation, and first another process is coloring. So three parts of the rotation process is, we can, if we divide the red black tree rotation process, there are three parts. First is ordering, second is coloring, third is rotation. Thank you everybody for the video, and please subscribe this channel for next video.